Okay, so we just finished studying polynomial expressions, and in that unit we learned how to distinguish between expressions that are polynomials and ones that are not, classify polynomials by their degree and number of terms, and then also perform operations like addition, subtraction, multiplication. Now what we're going to do is start exploring how to solve polynomial equations. We're going to start off with an example that is pretty straightforward and use it to help us develop techniques to solve equations that we have never encountered before. So let's get started. All right, let's take a look at the opener, and we're asked to solve the equation 2x plus 6 equals 0. Now you guys are all really good at solving these types of equations, so we're just going to quickly go through it. So we're going to subtract 6 from both sides of the equation and get 2x equals negative 6. And then we'll divide both sides of the equation by 2. And we're going to end up with x is equal to negative 3. So not a big surprise there. Again, you guys are all really good at solving those types of equations. So let's take a look at something like example number 1. Now, on example number 1, we're asked to solve the quantity x minus 4 times the quantity x plus 2 equals 0. Now, before we do that, what we're going to do is we're going to take a look back at the opener. So I'm just going to rewrite the opener down here. So 2x plus 6 equals 0. So if we look at that equation, what we're looking for are the values or the value of x that makes that statement true. And we found that in the opener, and that value is x equals negative 3. And we can check to see that that's true by substituting negative 3 back into the original equation for x. So let's do that over here. I'll grab a different color. So 2 times negative 3 plus 6 equals 0. 2 times negative 3 is negative 6 plus 6 equals 0. And negative 6 plus 0, I'm sorry, negative 6 plus 6 rather is 0. So 0 does indeed equal 0. So in this particular case, x equals negative 3 is the value of x that makes the left-hand side of that equation also equal to 0. And that's something that we want to keep in mind as we kind of work our way through the rest of this lesson. So I'm going to scroll down a little bit further here, and we're going to take a look at this discussion problem. Number 1 says, think of two different numbers that have a product of 0 and write them in the space below. So I'm actually going to use the number that we just found for x up top just because it's on my mind right now, so negative 3. So I'm thinking to myself, okay, what number do I have to multiply times negative 3 to get a product that's equal to 0? Well, that has to be 0. That's the only option that we have. Negative 3 times any other number is not going to equal 0. So 0 is the only option that we have. 2 says think of two other numbers, again, different than what you chose in number 1, that have a product of 0 and write them in the space below. So I'm going to pick another number, maybe, see, my lucky number is 22, so we'll pick that, 22. And again, I'm trying to multiply 22 times a number to get 0, and that also has to be 0. So the last question asks is, can you think of any two numbers not including 0 that have a product of 0? And the answer is no. Okay, one of the two numbers, or both, must equal 0 in order to get a product of 0. All right, so again, keep that in mind as we're working our way through this. So the key concept that we just developed here is actually really important, a really important idea when we're solving polynomial equations. It's called the zero product property. And basically all this is saying is that if the product of two numbers, so call them A and B, is equal to 0, and I'll highlight this for you. So if the product of two numbers is equal to 0, then A has to equal 0 or B has to equal 0. And we kind of just demonstrated this in the previous slide, or on the previous slide rather. So let's revisit example number 1 and use this property to help us solve the equation. So again, we have the equation x minus 4 times x plus 2 equals 0. Oops. So really what this is saying is, again, grab a different color pen here. One number times another number has to equal 0. So what I'm going to do, and if you look back up at the zero product property, this says one number times another number equals 0. I'm going to set the first number equal to 0 and the second number equal to 0. So in this case, the first number that we're looking at is x minus 4. So whatever x minus 4 is, I'm going to set that equal to 0. Or the second number, x plus 2, has to equal 0 in order for this to be a true equation. So let's solve those easy one-step linear equations. Add 4 to both sides and we get x equals 4. Or subtract 2 from both sides, we get x equals negative 2. So it appears that the solutions to this equation could be either x is equal to 4 or x is equal to negative 2. So let's check those answers real quick over off on the right hand side. So I'm going to check 4 first. So we're going to get 4 minus 4 times 4 plus 2. And we're checking to see if that equals 0. Well, 4 minus 4 is 0. 4 plus 2 is 6. 0 times 6 is 0, so 0 does equal 0 in this case. So that is a solution to the equation. And we're also going to check negative 2. Check negative 2. So we're going to get negative 2 minus 4 times negative 2 plus 2 equals 0. Tight fit there. Sorry about that. All right, so negative 2 minus negative 4 is negative 6. Negative 2 plus 2 is 0. So again, negative 6 times 0 is 0. So 0 does equal 0. So it looks like this process does work. All right, it gets us the solutions that we're looking for. So let's try a few examples down below. All right, I've got 3 of them. Now, if you'd like, you could pause the video right here, try these on your own, and then start the video up and check your answers once you're finished. Okay, I'm just going to start going through them right now. So the first example, again, we have 2 numbers that are being multiplied together, or their product is equal to 0. So I'm going to set each of those factors equal to 0. Then I'm going to solve the equation. So here m is going to equal 12, or m is going to equal negative 5. Now, due to time constraints here, I'm going to let you check those answers. Okay, I have checked them already and they are correct. For the second one, we have x times x minus 4 equals 0. So again, I'm just going to set each of those factors equal to 0. X equals 0 is already solved for us, so one of our solutions is x equals 0. We'll add 4 to both sides. We're going to get x equals 4. So again, our solutions here are x equals 0 or x equals 4. Again, I would check those if I were you. I have checked them and they are correct. And then finally, the last one, c plus 3/4 times c minus 6 equals, that should say equals 0. Sorry about that. So we're going to set each of those factors, again, equal to 0. So we'll subtract 3/4 from both sides. And then we'll add 6 to both sides. So again, our solution should be c equals negative 3/4 or c equals 6. So the zero product property is really important fact to know when you're solving polynomial equations, and it's something that's going to be really useful, and you're going to use it a lot, not only in this class, but pretty much in every math class that you take moving forward. Now, before we finish up this lesson, I just want to talk about one thing that you might be thinking about in your head. So the discussion question that I'm posing here is, so you might be thinking to yourself or asking yourself, why is this section called solving polynomial equations in factored form? So what I want to do is I want to look back again at the opener and also at example 1 and just answer this question. All right. So if we focus our attention, and I'm talking about the opener here, on the left-hand side of this equation, 2x plus 6 is a polynomial expression. This is a linear binomial. So this is a polynomial equation. Specifically, this polynomial equation is a linear equation. Now, if you take a look at example 2, it's not as obvious. Again, I'm focusing on the left-hand side of the equation. The last unit we studied, we learned how to multiply linear binomials like this together. We use that foiling technique or the distributive property. So I'm going to apply that right now. So x times x is x squared. X times 2 is positive 2x. Negative 4 times x is negative 4x. And then negative 2, sorry, that's getting so messy, times 2 is negative 8. So now if we simplify these terms down, we get x squared minus 2x minus 8 equals 0. So now it becomes a little bit clearer that the left-hand side of this equation is a polynomial expression, which means that this is also a polynomial equation. Okay, so that expression, x squared minus 2x minus 8, is a quadratic trinomial, which means this is a quadratic equation. So we'll be studying all types of different polynomial equations. And the cool thing is that if you can make something like this, so something that's in that standard form, look more like what we're seeing here. I'm going to erase all this stuff so you can see what I'm talking about. Get it down into its factored form, then you're going to be able to apply that zero product property to help you solve equations that really you've never seen or encountered before, at least polynomials. So that's it for this lesson. In the next lesson, we'll learn probably the most fundamental technique for solving polynomial equations that are not written in factored form, and that's finding a greatest common factor. I hope this was helpful, and we will see you in the next one.